final part of integration is finding areas now around the y-axis. So the ones we've done so far have all been about the x-axis. Now it's all about the y. So if you look at the diagram here, it's an area that goes from A to B. So it's like you've turned it on its side. And it's now coming down to the y-axis. If it's on this side, so where x is positive, then the area is positive, and if it's on this side, it's negative. So you remember, if it's about the x-axis, if it's where y is positive, up the top, it's positive, and where y is negative, then the area is negative. So this is just swapped around. And it's exactly the same. So B and A are now y values, and it's x dy. So last one was y dx. So we're now integrating an x. So you need to make x the subject in all of these. So our first example is, as reads, find the area bounded by the line y equals 2x plus 1, the y-axis, and the lines y equals 3 and y equals 4. Now it's a good idea, if you know the curve, then do a quick sketch of it. So we're even told it's a line in this case, and it's the line y equals 2x plus 1, so it doesn't really matter where it sits, except that we know it goes through the point 1, and we know it's a positive gradient, so it's something like that. And it's between that line, the y-axis, and the lines y equals 3 and y equals 4. So knowing that it goes through 1, there's 4 and there's 3. And that's the area we're wanting. So that's the line. So our area said it was equal to, from B to A, which in this case is 3 and 4, x dy. So at present we've got it in terms of y. We need to change that. So what we've got is y equals 2x plus 1. So we say 2x equals y minus 1. So get x by itself. And then we're going to divide everything by 2. I'm going to put that as a half y minus 1. So then it's the integral from 4 to 3 of a half y minus 1 dy. And then we check, is everything in terms of y? Are they y asymptotes? Sometimes the question can try and trick you and give you the whole thing in terms of y except for the boundaries. So if that's the case, what would you do? If they said x equals 3 and x equals 4, that's right, you'd have to sub in x equals 3 into the original to find the y value, and then the 4. You just substitute them in. Okay, and the reason I wrote it like this is that I can take that a half out. It's a bit easier than being on 2. So it's 4 to 3 of y minus 1 dy, and then it's a straightforward integration. So it's y squared on 2 minus y, 4 to 3. So it's 4 squared on 2 minus 4. Minus 3 squared on 2 minus 3. Big bracket there. So that's a half. And just do it in your head, guys. 4 squared, 16. 16 divided by 2 is 8. 8 minus 4 is 4. Minus. And we may need a bracket if this is negative, or just to be aware that that's going to change to a plus, which this one won't. So 3 squared is 9. 9 divided by 2 is 4.5. Minus 3 is 1.5. So it's 4 minus 3 on 2, and I'm just going to do this here. A half times 4 minus 1.5 is 2.5, or 5 on 2, which is 5 on 4 units squared. Can't quite fit the units squared in there.